Okay, today we're going to be talking about sum and difference identities. These identities are super useful. They are in section 7.5 of your textbook. So I'm going to ask you a question. Does the sine of 30 plus 60 equal the sine of 30 plus the sine of 60? So let's evaluate the sine of 30 plus 60. The sine of 30 plus 60 is equivalent to the sine of 90, which is 1. Now let's evaluate the sine of 30 plus the sine of 60. Well, the sine of 30 is 1/2 from our unit circle. The sine of 60 is root 3 over 2. That is not equal to 1. So the moral of the story is this. You cannot distribute the trig functions. Sine of 30 plus 60 is not the sine times 30 plus 60. There is no multiplication in here. And this distributive property applies to multiplication, and this is not a multiplication problem. So here are some formulas that you will need in order to add two angles and then find their sine and cosine. So if you have the cosine of alpha plus beta, it's equal to the cosine alpha cosine beta minus sine alpha sine beta. And then you have the cosine subtraction for when you're subtracting two angles, the addition, okay? These are called the sum and difference, the sum of two angles, the difference of two angles, and then your tangent formulas. So these are called your sum and difference identities. These two formulas can be derived a little bit different way if you're interested. So the tangent of alpha plus beta can be derived from taking the sine of alpha plus beta and putting it over the cosine alpha plus beta, because tangent is sine over cosine. Same thing here, the tangent of alpha minus beta can be derived from the sine of alpha minus beta over the cosine of alpha minus beta. So let's look at an example. Find the exact value of the sine of 105 degrees. Well, sure, we could do this with a calculator, but the calculator is going to give you a decimal and you would have to round. The question here is asking us for the exact value of the sine of 105 degrees. So we have to look for two angles on our unit circle that add or subtract to 105 degrees. So we can say the sine of 105 equals 45 plus 60, because in order to use these formulas, you need two angles that you know the sine and cosine of. Now, you could have chosen to use the sine of 135 minus 30. That's okay. Those have a difference of 105 degrees. So you would use this formula, the sine of alpha minus beta. But I'm going to go ahead and use sine of 45 plus 60. So if we use this formula, it's sine alpha sine beta equals sine alpha times cosine beta plus cosine alpha times sine beta. And that's from that formula sheet before. And as you can see, my alpha would be 45, my beta would be 60. So I'm going to plug 45 in for alpha, 60 in for beta. So what I have is I have the sine of 45 plus 60 equals sine 45 cosine 60 plus cosine 45 sine 60. Now the question, we just fill in what we know. The sine of 45 is root 2 over 2 times the cosine of 60 is 1/2 plus cosine 45 is root 2 over 2. Sine 60 is root 3 over 2. And now PEMDAS tells us to do the multiplication first. So root 2 over 2 times 1/2 is root 2 over 4. Root 2 over 2 times root 3 over 2 is root 6 over 4. As you can see, they have common denominators. So my final answer is root 2 plus root 6 over 4. Okay, so now let's look at the next example. Suppose the sine of alpha is 45 degrees. The sine of alpha is 4/5, and the cosine of beta is 7/25. Now, as you can see, they told me what quadrant they lie in. If alpha is between 0 and pi/2, it's quadrant 1. And beta is between 0 and pi/2, so it's quadrant 1 also. And they want us to find the cosine of alpha plus beta. So the first thing I'm going to do is draw a picture of alpha. And then I'm going to find the missing part of the triangle using Pythagorean theorem. Alpha is in quadrant 1 according to the problem. So here's a picture of alpha. It's in quadrant 1. I marked my alpha. I marked my angle here. Since the sine is 4/5, that's opposite over hypotenuse. By Pythagorean theorem, or knowing that this is a 3, 4, 5 right triangle, that side is 3. Now I draw a picture of beta. Again, beta is in quadrant 1 according to the problem. So here's a picture of beta. I put a beta in there. The cosine of beta is 7/25, so that's adjacent over hypotenuse. By Pythagorean theorem, where this is also a Pythagorean triple, this becomes 24. So now I'm going to use the cosine alpha plus beta formula. And you guys are going to do this. You're going to reduce your answer, find your sine and cosine values from the picture using SOHCAHTOA. So go ahead and pause the video, take a few minutes, write down the cosine alpha plus beta formula, then go ahead and plug in cosine and sine of alpha, cosine and sine of beta. You should get a pretty nice answer on this one. So go ahead and pause your video, work it out, and we'll give you the final answer when you start. So your final answer is -3/5. Did you get it right? Hope so. Okay, next example. Establishing an identity with the sum and difference formulas. Okay, so here's an identity. They're telling me that the cosine of pi/2 plus any angle theta is equal to the sine of that angle. The cosine of pi/2 plus the cosine of pi/2 plus theta is equal to the opposite of the sine of theta. So we're going to go ahead and prove this identity. We usually draw a line. So I notice here that I have a cosine sum. So I'm going to go ahead and apply the cosine alpha plus beta formula. My alpha is pi/2. My beta is theta. So if I apply that formula, it's the cosine of pi/2 times cosine of theta, and again, that formula is from that formula sheet, minus sine of pi/2 sine theta. Now I'm going to replace the cosine of pi/2 and the sine of pi/2 with their values. So the cosine of pi/2 is 0. The sine of pi/2 is 1. And now I'm going to go ahead and reduce. 0 times cosine wipes out, and this becomes negative sine theta. And you're done.